Before we start, if you don't have a model for dash one, and please develop the model for dash one first based on the previous tutorial. Okay, yes. So we are going to develop the model for dash two, and then so this is known as the enhanced electronic assembly and test system. Okay, and there are additional requirements for to develop this system. Okay, so system operates 2 shifts a day, and then 8 hours per each shift, okay, per shift. And then second shift, 2 operators working at rework, okay, rework process. So we have one more actually operator at rework process. And sealer machine has a failure problem. So really realistic, right? So sealer machine has a failure problem, and uptimes following the exponential distribution with the mean of 2 hours, and then repair time following the exponential distribution with the mean of 4 minutes. So please be careful about time unit when you modify your simulation model, especially model for dash one. And also, we want by rack to store the welding parts in the rework area. A rack can hold 10 parts, and in that case, we want to know how many racks we should buy. Okay. And we want to run, in order to evaluate this, we want to run the simulation for 10 days. So now finally we have an actual problem, right, to solve. Okay. So in order to consider all these new requirements, you have to update the model for dash one. That's why if you don't have model for dash one, and you should develop the model for dash one first. Okay, and then initially let's complete the easiest part first and go to the run setup. And especially you need to change the application parameter. So because you need to run the simulation for 10 days, not 32 hours. So you need to change the value as a 10 here, and then also change the time unit, right? And then define the day to be 16 hours. So hours per day should be 16. Why? Because we have 2 shifts, and each shift is 8 hours. So you have to change the day as 16 hours, right? And also, we have a schedule, and in order to actually consider the schedule, and you need to understand the basics of the resource schedule in Arena. Okay, and actually Arena allow you to vary the capacity of resource over time. That's a really good thing. I mean, to solve the realistic problem. Instead of resource in Arena has 4. So we have 4 states. One is idle, another one is busy, so inactive, failed. And idle, usually we use idle and busy. So idle means resource has not been seized by any entities. So it's available, in other words. Busy means resource has been seized by any entities. So it's working, but it's not available because there is the entity seizing the resource. Okay, that's a busy state. And inactive, so resource is unavailable for location, which means capacity is 0. Maybe you turn off the power of the machine, so that's why you cannot use that machine. Okay, so in that case, inactive state. Last one is the failed. Yes, if machine or resource is broken, and then definitely it's in the failed state. It doesn't have to be resource, doesn't have to be a machine. It can be also person. So if a person takes his or her sick leave, and then definitely also you can use this state. Okay, so if you go to the resource data module, you don't have to go right now. So if you go to the resource data module, and then for resource scheduling, and you can actually change the resource schedule. Okay, so you have, because I already you will have a tutorial for this model, so you don't have to really change any parameters right now. I just want to explain the basic functions or concepts using this simulation model. Okay, so in the second shift, you have a 2 operator at rework, so that's why you have to have the schedule. And there are 3 schedule rules. So one is ignore, capacity go down immediately for stat collection, but work goes on until finished. Okay, break could be shorter or gone. In other words, okay, so schedule, let's say you have a scheduled break time at this point. However, under the ignore rule, you will continue the current work and then take a break. Okay, and the work will begin at the scheduled break time end. So in this example, let's say there is a break time starting at 12 noon, lunchtime. Let's say there is a lunchtime from noon to 1 p.m. Okay, and then let's say it takes 15 minutes to complete the remaining work. And in this rule, under this rule, and then actual break time will start at 12:15 p.m. Okay, because there was current work, right? Work to do. So after that, you will take a break time, and then machine will start at 1 p.m. So actual break time is not 60 minutes, it's 45 minutes in this example. And there is another rule called wait. So capacity decrease wait until entity release the resource. So break will be full, but maybe start and end late. So there is a start break, and then there is a scheduled break start and a scheduled break end here. So same from noon to 1 p.m. However, the break will start at what, 12:15, because there is a current work, right? After that, you will have a 1 hour break, because originally the break time was 60 minutes, right? So you will take a 60-minute break, and then the another work will start at what time? 1:15 p.m. Okay, that's the wait rule. So different from the ignore rule. And last one is preempt rule. So capacity goes down immediately. It doesn't matter, okay, whether there is a current work or not. And the work will begin at the end of the break. So scheduled break start and scheduled break end. This is the easiest rule, right? And to calculate. So basically at noon there is a break, and then after the break end, and then there will be the work will begin again. So break time is still 60 minutes, and then break start at noon and break end at 1 p.m. So this rule is the easiest one, okay? And good for the employee, okay? Because you can take a lunch break at noon. Doesn't matter whether you have a work to do or not right now, right? So this rule is good for employee. And other two rules, especially the ignore rule, is miserable for employee, right? You will make a happy, I mean, employer will be very happy with this rule, okay? Okay, so there are two ways to schedule the data module, and then one is that you can use graph to schedule the data. And if you can, I think the previous older version if you use the older version, you can use this graph. And after the 8 hour, which is the first shift, and after 8 hours, you can actually increase the capacity, okay, of the work. So the local resource. So for the second shift, right? So this is the one way. And however, you can also change these numbers using the data module. Okay, especially a spreadsheet here. So if you click if you go to the schedule module, and then basically you can have a data module to specify the capacity. All right. And resource failure. Let's look at the resource failure. And also, yeah, so there was a resource failure, right? Cellular failure particularly. So if you go to the failure data module in advanced process panel, and basically you can actually specify this failure name, and then there is uptime and downtime, and as you know, exponential is what? Exponential distribution, right? So, and then here is the minutes, so that's why I typed the 120, and then this is also minute, so 4 minutes. So based on the based on the given statement, you can actually specify the uptime and downtime. And then if you go back to your resource, and then there is a failure column, right? And then just specify the name of the failure in the advanced panel, okay? And fail rule, let's use just wait rule, okay? And frequencies, and since we don't know how many reg we need, so we can actually collect the user specified statistic. So in order to do that, you can use the statistic data module. Okay, if you go to statistic data module, you can have this rework Q stat. You need to type it, and then type is a frequency, and then also value and expression will be nq rework process.q. So you will check the number of entity in the queue, because we will buy the queue to store the entities or part in this queue, right? Rework process queue dot q. So that's why. So, and then if you choose a category, you can specify the range. So start from 0, 0, 0, 10, 10, 20, 20, 30, 30, 40, okay? Because each rec can have 10 items, right? So that's why. So 0 rec, 1 rec, 2 rec, 3 rec, 4 rec is the category name. And then based on this category, it will check the frequency, okay? So this testing module will update the frequency. Anyway, yes. So yes, this is a detailed view of the statistic module. So rework, particularly rework Q stat. So you can have this category in this stat. All right. So once you have the model, and then you can run the model and then compare the performance of model 4-1 and model 4-2. So this model is a model 4-2 update version. Okay. So if you look at it, prep A, prep B, and similar, and rework. So waiting time is getting longer, because in model 4-2 we consider the what? We consider the machine failure, right? Right, cellular failure, right? So that's why. And also utilization of the rework is slightly lower than that of the model 4-1, because what? We hire one more person for the second shift, right? That's why here, right? And average time in system of the model 4-1 and model 4-2 are, of course, should be different. And then instantaneous utilization of resources is like this. So you may wonder what's the scheduled utilization and the instantaneous utilization of the resource. Okay, basically it's given by different equation. So this one is to measure the calculate the utilization over the time, and then at the end it divide this total utilization by T, large T, simulation runtime. However, the scheduled utilization is slightly different. This is capacity over the time, and then this is number busy over the time, and then divide by T, okay? So let's look at the definition, the difference between the scheduled utilization and instantaneous utilization. Good. So here's the graph of the MT, which give you the number of resource units scheduled, and then so it's a capacity, in other words, and BT is a number of resource unit busy, so number busy, okay? So, right. So if you look at it, and then here, if you get the shaded area of the empty graph, and then you will get 10. And then if you get the shaded area, size of shaded area, BT, integration of BT will give you 7. And then simulation runtime is 20. Let's say it's 20. And then you will get this kind of number. Okay, So, and then divide this number by this to get the schedule utilization. However, instantaneous utilization different. Calculate the utilization at each time. So 0.0, right? 0.0 for 2 minutes, first 2 minutes, and then 100%, right? For how much? 1, 2, 3, 4, right? And then also 5, right? Here, and this is a 0 utilization, right? And then calculate the utilization over the time, and other values are 0 anyway. So over time, and then divide the entire utilization by 20. Okay, so you need to develop another graph, UT graph over here based on these two, and then calculate the instantaneous utilization. So usually when there is a capacity change in the simulation model, and then usually these two utilization are different. Okay. All right, so simulation result, because you have a user-specified statistics, especially frequency, right? Frequencies. So you need to choose another report called the frequencies in the run setup. So if you go to run setup in report, and then basically you can specify this option frequencies, so that you can see the frequencies. Okay. And this is frequencies of each category, and there is no value for the 3 regs, 4 regs, 5 regs, and then number of observations like this, and restricted percentage for 0 regs, 1 reg, and then 2 regs are like this. So in my case, yes, how many actually you can actually determine how many the regs you should buy. Okay, maybe at most 2. You don't have to buy 3 because there is no case having more than 2 regs.